So I have a couple tips here. First of all, if you're plotting in Desmos to check your functions, instead of using x1 and x2, you can use x and y, and that way it'll plot correctly in Desmos. So here you can see where I've plotted problem 4.56. Well, it happens that 4.55 is the same problem except as a minimization. And I've got z in here as the function value, and it gave me a slider. Point 1 and point 2 are the two candidate solutions that you're going to find when you find the Lagrangian and take the gradient and set it equal to 0 and solve for it. So, and you can kind of see what's going on here. From a minimization standpoint, if I take z up, point 2 is the center, and point 1 is just a line where the constraint is active, so, or just a point on the line of the constraint. So when I go all the way down to minimization, that's at about minus 8.3, which is what the solution told you. Now that's for the minimization problem. If we look at this in the opposite direction, if I take the function value and keep increasing it, as we go in this direction, the gradient is going to keep increasing and the function value is going to keep increasing. So for 4.56, this is actually unbounded in the direction of the feasible region. So as a maximization problem, it's unbounded. As a minimization problem, the minimum solution is right here at point 2.